Let's talk about the argmin and argmax functions in Numpy and see how we can use them to find the index of the maximum or the minimum value in an array. So I already have here an array that I defined, and let's start by finding the maximum value in this array. So of course I can use the max function to do that. Now to use the max function I have two options. One option is to call it directly from the Numpy module. And if I use this way of writing, the parameter is going to be the array for which I want to find the maximum value. So R1 in my case. And let's see the maximum value. And indeed we got the maximum value in this array. The other way to write the same thing is to use the object-oriented way of writing. So instead of writing np.max, I'm going to first write the name of the array for which I want to find the maximum value. And then on this array, I can use the max function. And of course, I'm going to get the same result. So as we saw, this is the maximum value in this array. But let's now say that I want to find the index inside this array. So of course, it's going to be index 0, 1, 2, 3. And the argmax function can help us find this index. And once again, I can either call the function directly, and then I have to provide the array as a parameter, but I'm going to use the object-oriented way of writing. And let's run the program. And we can see that the maximum value is this, and the maximum index is 3 indeed, as expected. We can apply the same logic to find the minimum value of the array and the index of this minimum value. The only difference is going to be that we're going to use the min value and the argmin value instead of max. And you can see that the minimum value is 17, and the index of this value is index 1, so 0, 1. But what if we're talking about a multi-dimensional array? So instead of only having one dimension, we're going to have 2 dimensions. So now that we have a multi-dimensional array, we can keep using the same functions as before. So if we run the program now, we can see that the minimum value in this entire array is 17 and the index is index 1. But another thing we can do is to generate a new row with the minimum element for each index. So as you can see, I have 5 elements in each of my rows, and what I'm going to do is to generate a new row with 5 elements where each of these 5 elements is the minimum value among the options that we have. So for the first element, I'm going to choose 50 because it's the minimum among these values, 50, 603 and 1005. And then for index 1, it's going to be 17 because it's the minimum among these options, and so on. To do that, we need to pass the axis parameter to our functions. So right here inside min, I can provide the axis value, and since we want to generate a row, the index is going to be index 0. And I'll do the same thing for the argmin function, and this will generate a new row with the minimum values. So here we can see the new row with the minimum values, and for each of these values we can see the index, which represents the row the value was taken from. So the first and second values were taken from the first row, and then the next value was taken from this row, this is here, this is this 17, and so on. If you want to generate a column with the minimum values, we simply need to replace the axis from 0 to 1. And if we run this, we get a new column. So when picking the first value, all of these values were the candidates, and it shows the minimum value among them. And then for the next element, these values were the candidates, and so on. And for each of the values, we can also see the index of the column in the original matrix from which the value was taken. So for the first element, column 1 was chosen, and indeed we can see that it is this value. And for the second element, column 2 was chosen. So this element, and so on.